This is the Unit 5 seminar on algebraic equations. We're going to start with very simple one-step equations, and we're going to quickly escalate to dealing with two-step equations, equations that involve cross-multiplying, and fractions as well. So I need to see paper on every single desk. Just because I post these videos up eventually doesn't mean that I don't want to see you taking notes. So everyone get some paper out. Make sure you have everything you need to take detailed notes on this seminar. So the very first part of your guide and in your seminar sheet, you will be dealing with one-step equations. I have two examples here. Example 1, example 2. For example 1, I want to isolate my y. That means I only want y to be on the left-hand side. Everything else, all the numbers, need to move over to the other side. So on the right-hand side, we already have a 2. But this negative 8 needs to move over to the other side. Negative 8 needs to move over. What happens to the sign? What happens to the negative 8 when it moves over, Drew? Yes, it turns into a positive 8. So sometimes in your unit guide you will see the balance effect where you would have to add positive 8 to both sides. It's enough for me just to see that you know that when you're moving a number over to the other side, the sign in front of it changes. That is called transposing. So when you see this word in your unit guide, transpose, it's basically transferring your terms to the other side and the effect that it has on the sign of the number. So that means that my y is going to be equal to positive 10. Now, when it says to check your answer, what would I do to check my answer for this particular question? Check my answer. Drew? Exactly. Okay. So I'm going to show you an example of checking so you know that what I expect you to do on your test. So if y is equal to 10, I'm going to substitute that value into my equation. So instead of y minus 8, I have 10 minus 8 is equal to 2. And then I know that 10 minus 8 is equal to 2, so 2 is equal to 2. So basically, in order to confirm that your answer is correct, you have to write that the left-hand side is equal to the right-hand side. This has to be there in order to get full marks when you're checking your answer. If the left-hand side is not equal to the right-hand side, you would just put a slash through it. Left-hand side is not equal to the right-hand side. But that's what I expect to see when you're checking your answer. Okay, another example of one-step equations is when you have the multiplication factor. So I have 5x is equal to 20. I want to isolate the x. However, there is a 5 that is attached to the x. They've been multiplied together, so they're stuck together. How do I unstick the x so I can isolate the x? What operation do I have to do? Angie? Exactly. The reason why we divide is the 5 and the x are stuck together because they've been multiplied. In order to unstick them, I have to do the opposite of multiplication, which is division. But you have to do it to both sides. So the 5 cancels out with the 5, so that gives me x by itself. And x is going to be equal to 20 divided by 5, which is, what is 25 divided by 5 then? 4. X is equal to 4. And then I can go ahead and check my answer as well. So these are things that are probably not new to you. You probably saw them in elementary school. However, your unit guide quickly progresses to more difficult questions. So let's move on to some simple linear equations, which involve multiple steps. Okay, so not just one step. So for this particular question, 7x minus 4 is equal to 17. I know I want to isolate the x, and something that is very important is that you want your letters or your variables on one side Doesn't matter what side that you pick. And then all your numbers have to be on the other side. That's our main goal, having the variables on one side, the numbers on one side, separated by an equal sign. So I know that the only variable I have for this particular question is 7x. I have a 17 on the right-hand side. What has to move over, Angie? Is it 4 or negative 4? So the negative 4 needs to move over to the other side, and when that happens, it becomes a positive 4. So that's my transposition, transposing the numbers. So I have 7x is equal to, what is 17 plus 4, Aaron? What's 17 plus 4? 21. Okay. Now to isolate my x, what is the next step that I have to take? Kiana? Very good. I'm going to divide both sides by 7. So that the 2 7s cancel out, and my final answer is x is equal to 3. So basically, we combined both of the steps that I did in the previous 2 examples, all in one question. That's a pretty simple linear equation, very straightforward. But I did see on the Unit 3 test, kids, when you're moving numbers over to the other side, make sure you change the sign, okay? That's just the most common error. It's easily avoidable, so you want to make sure that that's something you do not mess up on your test. Okay, so this is it's just a little bit more complex. What concept do you see in this particular example that you encountered in Unit 3 and in our previous 2 seminars? What is it called, Ben? Distributive property. So remember, when you're doing your algebraic equations, you all learned about BEDMAS. And we have to pay attention to the BEDMAS rules in order to solve the questions accurately. Now, what does BEDMAS stand for? What does BEDMAS stand for, Drew? Yeah. Good. Brackets, exponents. So in this particular question, the reason we tackle the distributive property first is because we have brackets, and the distributive property involves brackets. So brackets, exponents, then we have division, multiplication, and finally we have addition and subtraction. So those are my BEDMAS rules, which I'm going to apply to this particular question. So first I have the positive number 2. I'm going to multiply that by 3x. Now what I saw a lot of people do on the test is, okay, positive 2 times 3x, and then 2 times 4. Oops. 2 times 4. What is missing? So I'm talking about the left-hand side. What is missing? Ben? The operation sign. The 2 is a positive 2, so we have to maintain that, okay? Whatever's in the brackets had 2 distinct terms separated by an addition sign. We still need to maintain that. If you didn't do that on your Unit 3 test, you lost some serious marks, okay? So keep that in mind. And that is going to be equal to 14. So 2 times 3x is going to give me what? 2 times 3x. Jacob, what do you think? 6x. And 2 times 4 is? Positive 8. Good. Is equal to 14. So remember what I said in the last slide. You want to keep your variables on one side, your numbers on one side. So what number has to move over? What number has to move over? Andy, look up here. What number has to move over to the other side? Positive 8. Good. So I want to maintain the 6x on the left-hand side. I already have 14. When the positive 8 moves over, it becomes a negative 8. Okay, so that's fine. 6x is equal to, what is 14 minus 8?